Alright, last example. Let's look at a hybrid circuit, something with some series resistors and some parallel resistors. The total current at the beginning of the loop, coming out of the battery, passes through R1 and splits into two branches. I've labeled them I1 and I2, passing through these resistors. After which they recombine here and are the total resistance again. Total current again. Okay, first, let's solve for the total resistance in this circuit. R1 is in series with 2 and 3, which are in parallel with each other. All of this here, in parentheses, handles the fact that those are parallel resistors. Total resistance. Is 220 ohms. Let's now figure the voltage drops after both resistor 1 and then 2 and 3. So the voltage drop across resistor 1 is the total current in the circuit, because that is the current flowing through resistor 1, times the value of resistor 1. I know this R1, but I do not know I total. So let's find I total. This is going to be the total voltage of the circuit divided by the total resistance of the circuit. Total voltage, total resistance. 1.5 over 220. 0.0068. Okay, now we can return back to our original issue. Delta V1 is I total times resistance 1. .682. That's the voltage drop across R1. The voltage drop across resistors 2 and 3 are identical to each other because they're in parallel. And that is going to be the initial source voltage minus this voltage drop across resistor 1 because of Kirchhoff's voltage law. So this will be 1.5 volts minus this delta .818 volts. is the voltage drop across these two resistors. Now let's go ahead and solve for the current through this first branch that goes through R2. Let's do this. Okay, the total current is going to be the sum of these two branch currents because of Kirchhoff's current law. We know this total, so let's find I1. V equals IR, so this current through I1 will be the voltage across resistor 2 divided by the value of resistor 2. The voltage across resistor 2 we found earlier, and the value of resistor 2 was given. .004 amps, and the current through branch 2 here is the voltage through resistor 3 divided by the value of resistor 3. Resistors 2 and 3 are in parallel. They'll experience the same voltage drop, but they do have different resistances. Recall earlier we said that these two should sum up to equal the total. Let's check that out. 0.0067. This is within the realm of a reasonable rounding error, 0.0068, 0.0067. So at this point, I could answer the total resistance, the voltage drop across resistor 1, the voltage drop across resistor 2 or 3, the current through resistor 2, the current through resistor 3. And there you have a hybrid circuit.